Hi everyone. In the previous video, we discussed about what DBT tests are, why are they important, and we did a deep dive into singular tests in DBT. Whenever we have to test a custom scenario, then we are going to take use of these singular tests. However, what if there are some columns which require similar type of test? Let's say there are a few columns, and in all these columns we have to check for null values or we have to check for unique values. So are we going to write one singular test for each of these columns? Absolutely not. That is not a sustainable way to create these tests, and that is when generic tests come into picture. If you're new here, then I am Radhika and this is my YouTube channel DataZard. If you are liking this DBT series, then please subscribe to my channel and hit the like button. And now without further ado, let's get started to understand what generic tests are. Let us first start with singular test. In singular test, what we were doing was, we were providing the model name. We were also providing the column name in the SQL query itself. And that is why we were saying that these are used to test out custom scenarios, because the scenario would be related to this model and this particular column. That is why they were called as singular test. However, for our generic tests, we don't want to test it on just one model or one column. We wanted to test for multiple models and multiple columns. That is why we cannot be providing model name and column name in the query itself. Instead, what we need to do is, we need to parameterize our query. Now, if you are coming from a coding background, then you would know what parameterized is. However, if you don't, then stay with me for a couple of minutes and I'm sure you will understand this. Let's take an example of Python programming language. In Python, whenever you have to write functions, then what you do is you give def keyword, because that's how you tell Python this is a function. Then you create function name. Then you provide function name, and then you provide arguments, argument 1, argument 2, etc. Any number of arguments you can provide. And then you provide the function body over here, which defines what work this function would do. So if you see here, why are we doing this? Why are we giving these arguments and argument 2, like all of these arguments? Because this is what is making this query parameterized. We can apply this on multiple different arguments. We can use this code for multiple different things. This is what parameterization means. We are not confining this function to be used for one scenario. Whatever you put as argument and argument 2, it will work on that particular arguments. So we are parameterizing it. We are saying that, hey, this is a general block and you can use it for anything that you provide which is acceptable by this function. Similarly, we can parameterize our query for generic test so that we can pass different model names, we can pass different column names, and in all of these models and columns, this generic test would be applicable. Now, what is the way to parameterize these queries? And the way to parameterize these queries is using Jinja templates. As you can sense by the name, these are templates. You can fill in different values here, and these values will correspond to different model names or column names. We will see them later on, but this is how you can parameterize it. So remember that when it is generic, you have to parameterize it, and the way to parameterize is using Jinja templates. So essentially what you do is you still write SQL query, which means, again, as it is DBT, so we'll still write the select statement, but we try to parameterize this select statement. Now, how to parameterize the select statement? Using Jinja templates. And this is how you create a generic test. Let us understand the full flow of how generic test works, as it is different from singular test. So the way this works is, first you create a .sql file. In this file, you will define a test block. This is a macro which will make use of Jinja templates so that you can parameterize this query. And in this, you will write your SQL statement or your select clause. Now after you do this, because you are parameterizing this, so we need to pass model name and column name. So how is SQL going to get this? We are going to use this in our .yaml file. Now you know from my previous videos that .yaml file is used to define properties. So yes, you are right. We are going to define data test properties of that in that particular model and column. So what we do is, we know that we have our model. Let's say we want to test model. We will go into the column that we want to test, and here we will define our test. So this data test property and provide the test name. When we do this, it not ends here, because when will dbt execute this test? When you will run the dbt test command, then only this will get executed. So there is a step added here. When we were just using singular test, then we were just defining the select clause in .sql file, and then we were just doing dbt test and the work was done. However, here we have to define the .sql file with a test block and then go to our YAML file. In the column that we want to test, define our data test properties over here. There are other things that go with this. We will see that later on. But define this in .yaml file and then do dbt test to run it. So it is a 3-step process. This is step number 1, this is step number 2, and this is step number 3. When we will be doing practical, then you will get more insights into it, and it is not a difficult process. It's just when I'm explaining this, it looks lengthy, but it is very easy. Now the next question that might be coming to your mind is, what are the resources that we can test? As I've already mentioned above, we can test models. We can also test seeds. We can also test snapshots, then sources. So there are lots of other resources that we can test. So it's not just limited to models. Now dbt provides 4 built-in tests. 4 built-in generic tests, I should say. These are really some common tests that you would do, that you would use in your day-to-day. First is not null test. So in not null test, suppose that we have columns A, B and C, and we don't want this C column to have any null values. No null values should be present. Then what we do is, on this C column, we apply the not null test. What this will do is, this test will capture all rows where C is null. Why? Because that's only what we want to flag, that wherever there are null rows, we want to flag them. That's why it's capturing all the rows where C is null, which means that if there are 0 such rows found, then this means our test has passed. But if there are n number of rows found, then we say that the test has failed and we will get our failed records. This is exactly what a not null test will do. It says not null, but essentially we are capturing null values, because then only we will know that whether this has passed or not. We will see the practical implementation just a little later. Let us move on to our next test. Next test, which is dbt's built-in generic test, is unique. Now what this test will do is, again let us go back to our model where we have 3 columns A, B and C, and we want that this C column should have unique values only. In this case, we can apply this test on C. So what this test will do is, it will capture failed records. And if you want to capture failed record, this means those records which have duplicate values in them. Those records will be duplicate records, and that's what will be captured by this unique test. So you will say this C should have unique values only, and if we get 0 failed rows, then this means it has passed. And if there are n number of rows returned by this particular test, then we would say that the test has failed, and then we will look at the failed records to see which are the duplicate values. Now the next built-in dbt generic test is accepted values. So let us again take an example where we have our model A, B and C are its columns, and this C is actually a categorical column, which means that it will have certain number of categories in it. Let's say the values here are alpha, beta and gamma. Now what we will do is we can apply a test on C, which is accepted values, and what this will do is it will ensure that only these values are allowed in this particular column. If it finds any other value, let's say delta, then that row will be captured as a failed row. And by this we will know that whether this accepted values test has passed or not. If there are 0 failed rows, then that means that the test has passed, and if there are n number of failed rows, then it means that it has failed, and we will know the values of what are the failed values available. And this is case sensitive. So if you have alpha written like this and in accepted values you have given that alpha should be like this, then this will also be flagged to you by this test. So as you can see here, these are very basic, simple tests, but these are very important tests which are used widely, and these are implemented also in a very simple manner, and we are going to have a look at it as soon as we finish our generic test theory. Now let us move on to our next test, which is called as relationships. Now this is another important test. This ensures that a value for this column, for a particular column where you're defining this relationships test, exists in another table. This is like a primary key, foreign key concept. So let's say we have a table which has rows A, B and C, and another table which has rows C and D. Now what we have is, this is the primary key of this particular table, let's say table 1, and this is the foreign key in table 2, which means all the values that are existing here should be existing over here as primary keys. This is what the relationship test validates, whether all the values that are present over here are present in this table 1 C column or not. This is exactly what a relationship test would do. A common scenario of this would be, let's say you are having an orders table and a customers table. So all the orders will have a customer column, and this customer column should be an existing column in the customers table to ensure that we have all the customers captured. So this is like a basic foreign key validation, which is important. These are the 4 tests. First is not null, then unique values, then accepted values, and then relationships. Now let us look at the practical implementation for all of these. So let us start the exciting part, where we are going to do the practical implementation of these generic tests. We're going to first apply these generic tests on sources. Now the definition of these generic tests is already defined by DBT. So we don't have to write these SQL files like we were doing for singular tests, because we are using these built-in tests by DBT. So all we have to do is we have to specify where we want to use it, and the place to specify these generic tests is in the YAML files. So these tests are defined as data test properties in the YAML files. So if you want to define a test on a source, then you go into the source YAML file. If you want to define a test on a model, then you will go into the models YAML file. And similarly for snapshots and seeds, you would do the same. You will go into their YAML files where you are defining the properties, and there you will define a data tests property which is going to specify these tests for you. So like I said, we don't have to create an SQL file for this because it is built-in test. So let us go into our bronze source file. So that's why I'm in bronze source.yaml, and here I'm going to define a test for age. Now the way to do this is, I will go into these columns. I have column name age here, we have description. Similarly, there is another property which is called as data tests. So I'm going to define that. And then we can stack all the data tests that we want to define for this particular column of source. So first, I want to define that I need a not null test here. And we can again give properties for this test. So we can say description, I want this description as age should not be null. So you can describe why you want to do this test or add whatever documentation you want to add. So you see how simple it is to use these generic tests provided by DBT itself. Similarly, let us go to our attrition column. Again, I'm in the source.yaml file, and here I'm going to define data tests. This is a property, and in this the first test I'm defining is not null. Now for this I can give a description, and I'm giving description as attrition is a core HR metric and we don't want it to be null. So I've defined the description for this particular test. Let us define another test on this. In source, attrition has yes and no values. So I'm going to define accepted values test over this one. So I'm going to say accepted values, and here again we can provide description. Only values that are accepted are yes and no. So now we have to define what are the values that are accepted. This is the description that we have defined. So the accepted values, they are defined in another property called as arguments. And in arguments, we are going to define values, and here we are going to pass yes and no as a list. So I'm passing yes and no. Remember that these are case sensitive, so the way you want the data to come in, you have to write it like that over here. Now we have done this basic part. Let us save this, and now let us just run this test. Now I'm going to run the test and show you something. So I'm going to do dbt test like we were doing with the singular test, and now this time I'm going to only run it on the source so that I can just show you how things are looking for source and we don't get confused between singular test and these generic tests all coming together. So the way to do this is I'm going to use select, and then we are going to define source, and our source name is staging. So we want to run these tests in staging source. Let's run this. So this will only run these particular tests that are defined in the YAML file. It is not going to run our singular test that we had defined earlier over here. So as you can see, there are three tests. First one is accepted values test. On attrition column, yes and no, it has passed. Second, you can see on age, it has not null test, that has also passed. And third, you can see on data attrition, it has a not null test, again it has passed. Now let us insert some values in our Snowflake so that we will build the models again, and then we will again see whether the test pass or not. Now let us go into our Snowflake and add a record here. The record that I am adding is such that my attrition becomes null. And the reason why I am doing this is because if we go to our source.yaml, in attrition column, we have defined that it should be not null, which means that when we will be running this test, then this row will get flagged to us in the failed records for this test. So I'm adding 100115 as the employee number here, and remember this should be coming as a failed record for us for that particular test. So let us just add this. And now once I have added this, let's go back to our DBT, and here I'm going to do DBT test. I'm just going to run select, and I'm going to run source, which is staging, so that we only run these tests which we have defined on the source. Now as soon as I run this, you're going to see the results. So the first result is for accepted values test on our data attrition, which is yes or no, this has passed. Then we see that our not null test on age has also passed, and the test that has failed is not null test on the attrition column, and we exactly know why, because we have inserted this record which should fail, so that I can show you the results and what happens. So you can clearly see here that failure in test source, it is telling us where it is at the source, which test it is not null test, and what is the table and column. So staging HR data attrition, it has failed, and you can also see here got one result, which means there is one failure in it. Now how to look for which row has failed? It's similar to how we were checking the singular results as well. You're just going to target, then compiled, and then models. And in bronze, we have bronze source YML. I will go over here, and then the test that has failed, let's look for it. So it is this not null on HR data attrition. So we can just copy this and we can paste it over here to see the results. I want to see all the columns related to this. So let us run this. And here you can see that this row is getting flagged, which is 100115, the record that we have inserted. So we are seeing this in the failed results. And if you see here, it is doing is it is selecting data where attrition is null, because we want to ensure that this particular column stays not null. That is why we have to check where attrition is null, so that we can capture those rows which are not adhering to our test and flag them. This is exactly how DBT is doing this. Now there is another thing that I want to point you out here, which is if you go here, pass is 2 because 2 tests have passed, 0 warnings, 1 error. It is saying that this is an error. But what if we don't want to show this as an error? Rather, we just want a warning for this because we can handle it, or it is not an essential column for us, let's say. In that case, it is easy for us to change this from error to warning. So for this, what we are going to do is we're going to go into the bronze source YAML file, and where we have defined this test in attrition, I'm going to add another property, and this property is called as config. And then we can set the severity as warned rather than error. So by default, the severity chosen by DBT is error, but we can change it to warned. Now let us just save this, and I'm just going to rerun this. And now you will see that instead of error 1, we're getting warning equal to 1. So you see it has changed from this red to yellow to show it is a warning. It is completed 1 with error. It is saying completed 1 with warning, and you can see here pass 2, warning 1 and error 0. So this is the config change that you have to do, and you can do this in your source.yaml file by defining config as a property. Now you can define the test and these configurations for all those tests in the source.yaml file. I already have the file ready so that I don't have to type it, and I'm just going to copy the contents of that file over here. And I'm going to push this code on GitHub so that you can access it via GitHub. Let me quickly do that. Now I have added the contents over here. So for each of these columns, what I'm doing is I'm adding a test, and I'm also defining the severity for that particular test by using the config property. I have done this for all of the columns, and now let us do dbt test, select, source, staging. And now you can see that I've defined 54 tests, and out of those tests, there are 2 errors. First one is in the source not null for data attrition. This is the 100115 employee that we have added. And the other one is in source not null created at. This is from the previous run that we had added. So these are being flagged to us by DBT. And to view what are these queries, we can go to this target compiled models, bronze model, and the source.yaml file, and all those tests are created as SQL files, and we can go to any of these files, run this SQL in our Snowflake, and figure out which is the record being flagged and fix those. So now you can see there are pass 52, error 2, skip 0. So this is how easy it was to use DBT's built-in test. Now I want to give an overview of what type of tests I have included in this source.yaml, so that when you're looking at my GitHub repository and understanding why I have written just a not null test or an accepted value test, or how I have decided that this should be warn or error, then that will make more sense to you. So the type of test that you should define in your source.yaml file, that is a test for your sources, is primary key constraints. Like if you know that a particular column is a unique identifier, then you should ensure that it has tests like unique and not null, so that you are capturing those values. And if these are unique and not null, if these are unique identifiers, then I would say that the severity should be error, because we want to stop the influx of data as soon as we know there is a problem with our unique identifier. Otherwise, it is going to mess up our pipeline down the line. Then the second type of test that I'm doing here is for categorical columns, which is accepted values. If you know that there is a column which is categorical and it has to have some of the values, like a typical set of values, then I would highly recommend adding an accepted values test. And it could depend if you want to put it as a warning or error because it is at a source level, but I have mostly defined this as errors because I want to flag those unexpected values straight away, fix them, and then only ingest my data. So that is why if you see here, attrition was a categorical column, and for accepted values test I have said it should be error. Then accepted values for business travel is also error, so I'm flagging these as errors. The third type of test is we should normally test for not nulls because some fields they should normally exist but they may occasionally be missing, like age. So for age I have defined this test as a not null test. I have kept the severity as warning, and the reason for that is it could be null for any particular reason. We have not got the data or anything, so we are just flagging it. We are not stopping the ingestion of data. So we are raising the warning so that the issue can be investigated without stopping the data processing. Now, it is highly important that source tests do not enforce any business logic or any transformations. These will belong in our downstream layers like the silver, gold, or bronze, wherever we are going to define them. So we should not have tests like salary thresholds or tenure logic, any derived calculations, any analytics validations, etc. For example, if you want to check that the total working years is less than age, you would normally this will be implemented in a transformation layer rather than at the source layer. We don't want to stop data because of this, and this does not belong at the source. So that is why it is important to first think of what type of test should be present at this particular layer and then write those tests. Now this video has already stretched too long, like it's 28 minutes already. So I would like to wrap it up right now. I know we have not covered generic tests, which are custom generic tests in this particular video. So I will be covering that topic in the next one. So watch the space. For now, let us push these contents on GitHub. So I'm going to say git status. So this is the file that we have modified. I'm going to add this to the staging area in GitHub. Again, I'm going to check the status. And then let's just commit this code. So I'm going to say added generic tests built in. And now I'm just going to do git push origin main. And this has been uploaded to my GitHub repository and you can watch it over there. If you have any questions related to these generic tests, especially these built-in generic tests in DBT, then please put your questions in the comments below. I promise you that I will get back to you on those. If you have any feedback for me, then also put that down in the comments below. I would love to hear from you. So please put that in the comments. Thank you for watching. I will see you in my next one.